This is my 1968 Electrolux Penta E-50 outboard motor, which I bought for just $50. In the previous video I tried to fix some of its biggest problems and bring it one step closer to running properly again. It looked like almost everything was fixed, but three serious problems remained. No cooling water, heavy smoke, and very rough running. So today I'll focus on these three issues and hopefully get this old engine running the way it should. I will start with the cooling water pump. Normally water should be spraying out of this inspection port, but in my case nothing is coming out, so the pump clearly isn't moving any water. I was almost sure the impeller had slipped on the shaft again. The 2 extra pins I added last time probably still weren't enough. But when I turn the shaft, I can actually see the impeller spinning through the pump outlet. The pump housing looks fine. The impeller looks fine as well. No signs of slipping on the shaft either. The pins I added last time have already started to rust. I was planning to replace them with a woodruff key based on one of the comments. But since they held the impeller in place, I'll just swap them for stainless steel pins. One comment suggested checking the middle section of the leg for a blockage or a possible water leak. I made a temporary clear cover for the thermostat housing to see if water was reaching the top. Then I used an external water pump, controlled the pressure with ball valves, and pushed water through the engine. But there was no blockage and no leak. Water flowed through the engine, back down into the leg, and partly out through the inspection port. Then I realized I could test the pump outside of the outboard. I got a new branded impeller. The listing showed a brass hub, but this one came with a plastic hub. With 3 pins holding it, it should still be fine. But before that, I'll try an experiment suggested by this comment. It's a 3D printed TPU impeller with an ABS hub glued in using 2-part epoxy. It flexes almost exactly like the original rubber impeller. To fit the shaft into the drill, I made a simple adapter from a hose and a smaller round bar. And it works, so once again I found no problem here. So let's put it back together and see if the 3D printed impeller survives at higher RPM. One comment gave me another idea. The exhaust is right next to the water intake, so without the propeller it might be pulling air into the pump, but with the propeller installed the barrel probably wouldn't stay full for long. So I'll try redirecting the exhaust gases farther away with a plastic fuel can spout. It was the only thing I had that fit this well. I also found out from one of the comments that each cylinder has a different ignition point gap. So before the next start, I'll adjust them properly. And based on this comment, I'll try mixing the fuel at a different ratio again. We have water circulation. but the temporary clear thermostat cover is leaking a little. I let it run for a few minutes. At low RPM, the water is still circulating, so now I'll give it some throttle. As soon as I gave it a little throttle, the water stopped circulating, and honestly, the engine doesn't want to rev up very well either. Maybe it's because of the ignition point gap adjustment? Actually, no, it was probably just air in the fuel line from tilting the engine while removing the lower unit. Maybe the pump lost its water prime again? The impeller is a little deformed in a few spots, maybe more infill would help, but it doesn't look destroyed. So I decided to stop experimenting and install the proper branded impeller. Apart from a few markings and small details, it's almost identical to the unbranded one. So based on this comment, I started replacing the lower unit bolts with stainless steel ones because the zinc plated bolts had already started rusting after just a few weeks. And after this comment, I made sure to use marine grease everywhere. I also followed this advice and used marine grease on the drive shaft instead of copper paste. This time I'll try separating the exhaust from the water intake with a cut-up plastic bottle. To keep some of the water from splashing out, I'll partly cover the barrel with styrofoam. The engine is warm, so let's give it some throttle. The cooling problem seems fixed. Even at higher RPM, the water keeps circulating, so separating the intake from the exhaust probably helped. But the engine still smokes a lot and runs rough. Thanks to this comment, I finally found a thermostat that should fit this engine. Hopefully the thermostat will help the engine warm up properly and run better. But honestly, I don't see much difference. I also found out that compression should be tested with a warm engine and the throttle fully open, and last time I did neither. But the gauge still shows the same pressure, so I'll try connecting it another way. Okay, that's already much better, but it's still too low. So this seal is clearly not doing its job. Even on the second cylinder, it still seems to be about 25 pounds per square inch, or around 2 bars too low. And the third cylinder is even a bit lower. But I still have some doubts about this compression test, so before taking the engine apart, I'll check the second cylinder's ignition condenser, because I already wasn't sure about it last time. Last time, the positive wire had cracked insulation, and it looked like it was loose inside the condenser. I found a new one with the same size and specs, so I'll solder the bracket on and mount it back in place. Just to be safe, I'll check if it's getting spark. Great, so the spark is there. But even this didn't help, it still smokes badly and shakes like crazy. Then I thought I could disable the cylinders one by one and see which one is causing the problem. But in the end, this test didn't really tell me much. Depending on the crankshaft position, one cylinder might not be able to keep the engine running, while another one might. Before going this far, I wanted to make sure all the other problems were solved, but now I'm finally doing what I probably should have done much earlier. I'll split the engine apart and check the piston rings. I'm really glad these long studs came out. Drilling them out would have been a nightmare. The second to last one didn't want to move at first, but eventually it came loose. But the very last one, of course that one was completely stuck. After drilling, the part finally started to move, and I managed to work it out a little. But in the end, I had to cut the stud with bolt cutters. The piston rings look fine, they're all intact with no broken rings. The pistons look good too, apart from one scratch, there's no real damage. And the cylinders? The first one looks fine. The second one too. But the third one, that's a disaster. It's scratched up and the cylinder coating is flaking off in several places. Judging by the top of the cylinder, it looks like something was bouncing around in here at some point. The cylinder wall is marked and scratched up, but the piston itself looks fine, so maybe someone already tried to repair this engine and replace the piston. The crankcase cover is damaged too, with deep marks inside, and some of them look like they may have already been ground down by someone before me. Before touching the cylinder walls, I checked them with a magnet. If the magnet sticks, it probably has a steel or cast iron liner. If it doesn't, it's likely an aluminum cylinder with a special coating, and honing it could ruin it. The magnet doesn't stick, so this is most likely an aluminum cylinder with some kind of special coating, and that's not something I can properly fix in my garage. Just replacing the piston rings and ignoring the damaged third cylinder doesn't feel like. So for now, I have to call this project a personal fail. I should have opened the engine much earlier. It would have saved me a lot of unnecessary work. But there is one positive thing. I talked to the previous owner, and he said he never had the engine repaired. It had always smoked a lot. As an apology, he sold me another old outboard for another $50. It's much more powerful, but it was used for a parasailing business and hasn't run in over 20 years. So, who knows what kind of problems are waiting for me with that one. And yes, it's another 3-cylinder engine, so don't forget to subscribe and I'll see you in the next video.